Whether you're working on a big coding project or a simple little script to solve a problem, you have to test the code you write. We've all had experience with software that doesn't work the way it's intended. On complex programming projects like a cutting-edge computer game, maybe it's inevitable that there will be some bugs or issues. But our goal should always be to write code that works exactly the way it's supposed to. And honestly, on the relatively simple programs we make as beginners, we shouldn't settle for anything less. To achieve that, we need to have a strategy for testing our code. As a beginner, you probably don't think much about testing. Your process is to read the directions, write the code, and run it. If it works, go turn it in. If it doesn't work, try and figure out why. Eventually, that might devolve into just trying random things and hoping it works, or maybe even giving up and turning in whatever you have. But if every coder worked like that, big and complex software projects would never get done, or at least they'd never be usable. And even simple projects would be a mess. So, how do we test our code? The complete answer to that is complicated and well beyond the scope of this course. But we can start with a basic strategy that will help you now and will be a good foundation for more advanced testing techniques later on. Okay, there are a few things we have to accept in order to build that foundation for solid testing. One, you're going to make mistakes. That's just part of being a programmer, or at least it is in my experience. Maybe there are programming savants out there who just have code spring from their heads fully formed and perfect, but I've never met one. I know I make tons of mistakes, and I know that you will too. Hopefully that's also a little comforting, since it means you don't have to feel bad if you keep messing things up. Two, nobody likes testing and debugging, but it's part of being a coder. Okay, I'm sure there's some weirdo out there who loves it, but again, I'm not sure I've ever met that person. Writing the code feels exciting and creative, and we think of testing and debugging as what we do afterwards. But we need to accept that testing and debugging are both part of the programming process, not something separate. And three, you need to think about testing before you start writing code. Those first two are just facts of life. You can deny them if you want, just like you could run around saying the sky isn't blue. But, look out your window. The last one, though, is the toughest to convince students of, and it's the easiest one to forget or ignore. Coming up with a testing strategy is part of the planning we should be doing before we fire up our IDE to start a new program. In this course, our testing strategy is going to be based on the idea of test cases. A test case is the data we use to make sure our code works correctly, along with the output or result we expect to get. Think of it as what we try the first time we run our program. And that last part about the output is important. We need to know what our program should do before we create it. Otherwise, how can we write the code correctly? As a really simple example, let's consider a program that takes two numbers and calculates the sum. A test case for that program might look like this. The numbers on the left are our inputs, the two numbers we're adding together. I'm not using the word input in the literal sense that they were typed in by a user. Sometimes that's true, but often I'm just putting the numbers directly in my code. But I'll still refer to them here as inputs. The number on the right is the output or the result that we expect to get. If my inputs for this program are 3 and 3, then I expect the output to be 6. Now, this is a really simplified format. I've got my inputs or my data listed on the left, and then I used a minus sign and a greater than sign to draw a cool little arrow, and I put my expected output on the right. And remember, I still haven't written any code yet, but I've thought about this program, and I know that when I run it for the first time, I can put in 3 and 3. If my program produces the output I expect, which is 6, then it has passed this test case. If it produces something different than what I expect, then I've got a problem and I have to work that out. Okay, but why do we have to create a test case first? Why can't I just know that I'll type in 3 and 3 and see if it gets a 6? First, creating test cases helps you understand the problem. That's especially important if you're a student because your teacher or your textbook is giving you directions for the programs, and sometimes that can be confusing. You may not understand what it's really asking you to do. That sounds insulting, but it's actually not uncommon at all for a student to read the directions and jump right into writing code, even if they haven't figured out how the calculations or the logic should work. Yeah, I'll figure that out when I get to it. But creating the test cases gets you thinking about the steps you'll need in order to solve the problem. If the program adds two numbers together, that's not very important. It's a really trivial task. But imagine that you've been assigned a problem that asks you to calculate the area of a rectangle with a circle cut out of it. Still not the most complicated program in the world, but a step up from addition. To start with, I'll need to calculate the area of the rectangle. In this case, I happen to know that the formula is length times width, so I know that those are the two pieces of data I'll need, but this is the point where I would stop and figure that out. If it's something I don't understand, I need to go research it or ask for help. Once I've calculated that area, I'll need the area of the hole in the center. So again, I can go look that up if I need to, but I happen to know that I'll need the radius for that because the formula is pi r squared. Now, once I have the area of the rectangle and I have the area of the circle, I can subtract the area of the circle from the area of the rectangle and I'll have my final answer. Coming up with a test case has forced me to figure out those steps, and it also helps me know what variables I'll need. From this process, I see that I'll need variables for length, width, and radius, and I'll probably also need variables for the area of the rectangle and the area of the circle to store those calculations. And of course, I'll need a variable for the final answer. This mindset is important. Students sometimes think, well, I don't know how to solve the problem. I'm going to write the program to do that. But you can't write the code if you don't know what it's supposed to do. It's okay if you can't do the math yourself, because at this stage I can just use a calculator to do the arithmetic for me, but I still need to know what to do with the calculator. This kind of planning saves you a ton of time in the end, because now you won't be fumbling around trying the wrong things when writing your code. Okay, so maybe you're kind of starting to accept that there's value to this, but here's where I'm probably going to lose you. One test case isn't enough. The more complicated a program is, the more test cases you'll need to ensure that it works correctly. So the inevitable question is, how many test cases do I need? Unfortunately, the answer is enough to thoroughly test your program. But that's kind of a smart-ass answer and not one you want. In a professional setting, even a simple program or method will have a ton of test cases, or what we might call unit tests. But I know students want a specific answer. If you're going to force me to give you a specific answer, I'm going to say 3. You need to have 3 test cases. The truth is, 3 is almost never enough, but my goal here is to help you develop a test-centered mindset when you code, not to make you angry. So for my assignments, give me 3 test cases for every program you write. So how do you choose those test cases? The first test case can be a really simple set of numbers. If the directions for the problem include an example or even some sample output, you can use that for your first test case. I didn't say you had to invent these yourself, you just need to have them and understand them. And at least one of the 3 test cases should probably be a weird set of inputs. Maybe that's a negative number or numbers with weird decimals or even zeros. Those things are all valid tests. And a couple other things to think about. One is, you might consider a test case with extreme values, like really big numbers that might not even be realistic. Another thing is what we call edge cases. An edge case is a test case that's either right at the limit of what your program can handle, or it's right on the edge of 2 different outputs or behaviors. For example, if you're writing code that finds somebody's letter grade based on their percentage, 89.9 is an edge case. That's a B, but it's really close to an A. 90.0 is an edge case as well. The idea is those are values that are right on the edge between 2 different outputs. So when that's appropriate, include an edge case or 2 in your test cases. Okay, now we know what test cases are and we're all excited to do this before we even begin writing code. So let's take a look at how to write them. In your life beyond this class, you're more likely to do test cases in an automated way using a testing framework. This is that idea of unit tests that I mentioned a few minutes ago. For this class, I just want you to write your test cases at the bottom of the comment block you're already putting at the top of each file you create. And honestly, the format doesn't really even matter to me as long as I can find them there and as long as I can tell what your inputs and expected outputs are. Here's what test cases for the adding program might look like. Again, there's nothing special about this format, it's just how I tend to do mine. Notice that they are complete. As tempting as it may be, we don't want to just leave the output part blank and fill it in when we run our program. If I run this and get a totally different number, I have to stop and decide, does my program have a flaw or is my test case wrong? Whichever it is, you need to go fix that. But think carefully before you just change that output to match what you're getting. The problem probably wasn't my test case. And just so you know, in my classes, I grade your code by looking at it. Even if it doesn't work correctly, you can get points for being close or even just making a good attempt at it. So I'd rather have you just leave the test case alone if you know the code is wrong. That way, I'll see that you're aware of the bug and maybe I can help you fix it. It's important for me to know that you at least understood the problem and you got your test cases right. If you're not sure how to make that work in code, I can help you with that. And if you're not understanding how to do the math, you definitely should ask. This isn't intended to be a math class, so I'm happy to help you understand what's going on. And know that test cases still apply even if the program isn't doing any math. Let's say I need to write a program that lets the user enter a state and it outputs the capital city of that state. I might not know how to write the code for that yet, but that's the point. I can still write my test cases, and while I'm doing so, I might be able to figure some things out about how it works. For my test cases, I might want to test what happens with weird capitalization, or if the user enters a state that doesn't exist. So those are good test cases. Okay, I just want to wrap up by acknowledging that this is a giant topic, and an important one, and an unpopular one. I want to remind you, you're not going to learn everything you need to know about testing right now. The goal here is to show you how to write test cases because they're going to be required on your assignments going forward. I also want to acknowledge that I can't really tell whether or not you did your test cases first. I'll have no idea if you just suddenly remembered them right before you submitted your work and threw them in there by running your program and typing it in. But my hope is that you'll use test cases to help you plan your program because it's going to make it easier to solve complex programs as we learn more advanced stuff.